reducers, each one works on a single element or a key value pair. And we can combine them together to create this map task. The output of the function is either a 0 or 1. Or even more key value pairs. So the system will sort all the key value pairs by key. And when it does that, it forms a list of values or pairs. So when this is done, the output of this map it will be given to another function called the reduce function. So another function reduce, which is written by us, the programmer, is applied to each key and list of values pair. The application of the reduce function to one key and its values is a reducer. Now they could be the same as with the mappers. There could be a lot of reducers, and when we combine them together, we will get the reduced task. So the reducer gets one key and its list of values. If there could be a number of reducers, and when that happens, all of them combined together is the reduced task. The output of this entire job is the union of all of these reducers. So you get the job, there is a bunch of mappers that produce an output. Each mapper works on a single element. The reducer takes one key and its values. There could be a number of reducers, and finally we'll combine them together and to produce the result of this job. So this is how it looks like. These are the mappers. Each mapper gets a single element, key value pair, does some computation. Each mapper could be on a different node. There is a one-to-many relationship here. So the output from this mapper can go into 3 different reducers. So there is the reducers again will get the output from the mappers and produce reduce output. Each one does that separately, and finally we combine the reducers to get the output of the job, of the whole job. Let's think about a word count example. And so let's see an example of that. So we have, let's think of some text file, a document that contains text. So the document contains a bunch of words. It's a sequence of words. We want to count the number of times that each word appears in the file. So we or you could think of it as it's a document, or it can be a number of documents. In this case, doesn't matter if we have a number of documents, we can still feed them through the same system. The document could be given as an input element to one of the mappers. So let's see how that works. The map function will get key and value as its input parameter, and that's a single element. So if, let's think that we have a number of documents in the input. So the key could be the document ID, and the value can be the text of the document. So next what we're gonna do, loop through the document, because the one mapper is processing one element, so it takes one of the documents, and now it's gonna loop through this one document for each word in the value is the text, then emit W, the word ID, and the number of times that you have seen it there. So for each word W, in the value, that is the text. For that word, we will produce a 1. So we're just counting here. Every time we see that word, we will output the word and a number next to it. And usually all the numbers will be 1 in that case. We could have what's called a combiner function that will sum these numbers for that word. In the reduce function, it will take the key. In this case, the key will be the word, this W here, and a value list. A list of how many ones we encountered, how many ones were produced by this map function. So a list of ones. Or if it was a combiner, then it will might get more than 1 for that particular word. So the key is the word, and the value is a list of integers. And so for each integer on the value list, increment. Basically, it's adding the numbers together for each word. And then it will output the word and the integer, or the number of times that word was encountered. Now, what if some of the nodes will fail to execute the map task or the reduce task? What are we going to do in that case? So, the environment, this clustered environment, we will need to re-execute the failed tasks. So there is a way to determine if a particular mapper failed and redo its job, instead of having to redo the whole job. So we can find specific mappers or reducers that fail. So these MapReduce tasks do have a blocking property. That blocking property is very similar to the atomic transaction in relational databases. So if you have taken the database course, and you know when we are updating the records, either we finish completely the update of the record, or we don't do it at all. So there is no middle ground. So if we're in the middle of updating a record in a database and the power shut off and the computer shut off or crashed, then that transaction, it either was fully executed or we forget about it. We don't do it at all. So that's called an atomic transaction. This way it guarantees that it's always finished or it's not started to begin with. So this is the same situation. If the MapReduce task failed in the middle of the execution, we will discard whatever it executed until that time, and we rerun it again. If it completed fully before the crash happened, then we can take that output that was produced. So if we have this blocking property, then we can restart the map task that failed without fear that, let's say, a reduced task already has taken some output of the failed map task. Because there was no output produced until it finished completely.